Everyone, I am Pranav Patil, an enthusiastic electronics engineer. In this video, I will explain my project, FSM-based electronic voting machine using Verilog HDL. So, this project uses a finite state machine architecture with the two operating modes. The first mode is voting mode and the second mode is the tally mode. The machine supports 4 candidates, prevents duplicate voting, and display the final vote results. So let's start with a block diagram first. On the left hand side, you can see the inputs: clock signal, reset signal, mode selections, voter ID, and vote buttons. On the top of it has A, B, C, D. These inputs are connected to the FSM voting machine, in which the controller is the main brain of the systems. Its responsibilities are: it checks the operating mode, receives the voter ID, verify the duplicate voting, it processes the vote, update the candidate count, move through the FSM states. At the output side, you can see it has a count A, count B, count C, and count D. So these counters stores votes for each candidate. So finally, during the tally mode, the machine displays the vote results. So now let's go with the logic based, where machine starts, then it resets the initialize the machine enters the ideal state. After that, it checks the mode. If the mode is 0, the system enters into the voting mode. The machine receives the voter ID, then it checks whether the voter has already voted or not. If the voter had already voted, the vote gets rejected. If not, the voter selects a candidate. The candidate counts increase, then the machine return back to the waiting state. When mode becomes 1, the machine enters into the tally mode, where vote counts are displayed, and the machine stops accepting the votes. So now let's understand the FSM design. I implemented it with the 6 states. First one is ideal state, wait for voter state, voting state, vote cast state, log state, and the tally state. So this state flow is like this. Ideal moves to the wait for voter checks modes, voting waits for user vote input, vote cast update the vote count, so log prevents duplicate entries, and the tally display the result. Using the finite state machine helps control the system in an organized and hardware friendly way. So now let me explain the important section of the Verilog code. Here is the Verilog code where I have captured the code snap. Yeah. So here I defined all the FSM states. As you can see the parameters, where the register voter with a 0 is to 15, it adds the memory to stop the duplicate voting. For example, if the voted indicates as 1, then it is voted. If the voter 7 indicated as 0, then the 7th voter is still to vote. This array stores whether a voter has already voted or not. So now let's get into the state transition logic. Okay, so the important here is, as you can see, the voting. If voted, voter ID is equal to 1, next state is equal to log. So this checks the duplicate voting and detect the vote input. So now we'll get into the vote count logic, whereas the logic is like, so here, this is where the actual voting happens. So these codes indicate the vote processing logic. For example, if vote count is A less than or equal to vote count A plus 1, this increments the candidate A votes. So it also log this voter where voted with a bracket of voter ID less than or equal to 1. So this line prevents the duplicate voting. This resets all the counts and clear votes history. So now let's get into to simulate this project where I use the Icarus Verilog and GTK waves. Let's do the simulation part now. We'll go to the new terminal. Did it come? Yeah. Just go with the iVerilog. It has given us the voting simulation. Now we will VVP it. Okay, now as you can see, the dump VCD has been obtained from this. So we got it as the vote result for A is equal to 1 and C is equal to 1. Now we will observe its waveform analysis. So GTK dump view. Yes. As you can see, the waveform analysis are here. When I click into the TB voting machine, you can see this register clock counts with the inputs, outputs with a mode and reset. Also, you can see the UTT also here, like with the input states with its output. So now let's get into it. What we will do, we will first take out the reset mode. We'll first take out the reset mode and we'll take the voter ID with vote A, B, C, D and the next state mode with also current state mode with its clock mode. We'll append it and we will run the simulations now. We'll run the simulations. As you can see, the clock has been simulated with the 100 nanoseconds. The current state for A voter, for the reset it is 0. For the A, you can see it has a 1. You can see it has a 1 here with the state of 010 and with the next state of 011. Here we goes for the voter B and also here we go for the voter C. Thank you for watching my videos. Any suggestions are welcome. Thank you one and all.